Hey everyone, my name is Yograj Sikka. I am student of Center for Global Education at Chitkara University in collaboration with Deakin University, Australia. Today I am demonstrating my task 3.1p, which is create IFTTT trigger of unit SIT210, which is embedded system. In this we had made a small embedded system to monitor the sunlight exposure for terrarium and notify the user when the sunlight starts and stops. The device uses an Arduino Nano with BH1750 light sensor to measure the light in lux. When predefined light thresholds are crossed, the board sends the notification to the user using a secure webhook to IFTTT webhook, which in turn sends a notification. The system all accumulates daily sunlight time and reports it when sunlight stops. Our main objective is to notify the user via IFTTT notification or email on each start and stop event with lux and timing information. And then we had used many hardware components like Arduino Nano, BH1750 light sensor module, power or USB cables, and jumper wires. Let's after that we had made a applets. Here are two applets which I had made using different commands. First is sunlight started and then other is sunlight stopped. So let's see the code. Here is the code of my project. The code defines firstly the code defines wire.h include, which enables the I to C communication so the Arduino board can talk to BH1750 light sensor, and BH1750.h provides ready-made function to get light intensity in lux. Wi-Fi Nina.h to connect the Arduino Nano to the Wi-Fi, and Arduino HTTP client.h to allow the board to send the secure HTTPS request to external services like IFTTT. Next, the code defines user setting. This include the Wi-Fi or SSID pass. So after that, we had made IFTTT host, port, and key. Here we had given the key which is given on IFTTT app, which is separate for everyone else. The threshold values for light detection are then set. Since the BH1750 measure lux, the code consider any reading above 200 lux as the start of sunlight and my reading below 100 as the end of sunlight. This create a buffer to avoid false trigger due to flickering light levels. After that, the program declares object and variable. A BH1750 object is created to read the lux, and Wi-Fi SSL client and object ensures encrypted HTTPS communication, and HTTP client object handle sending request. State tracking variables are defined in sun to record whether sunlight is currently state changes or state changes, and to store the value a sun today ms to accumulate today sunlight for the day, and day start ms to know the reset daily counters. The first function connect wi-fi the first function, which is connect Wi-Fi, is made to which is to make sure the Arduino is connected to Wi-Fi. If it already connected, the function exists. Otherwise, it prints a message to serial monitor. Repeatedly tries to connect using the saved SSID, and once connected prints confirm along with the device's IPs. The read lux. So here you can see readlux. Readlux function is a simple wrapper that returns the lux value from the BH1750. The send IFTTT event function handles communication with IFTTT that ensures Wi-Fi is connected, then builds the correct URL webhook key. And after that, we can hold up three value 1, value 2, and value 3. Here you can see which we had given by V1, V2, and V3. After that, the check sunlight function is made. Is it is to function is the heart of the state machine. It finds first reads the current lux and current system time in millisecond. If the device is not in sunlight and the lux rise above the highest threshold, then it will then it will send a notification using an IFTTT, which is sunlight started. After that, if the device is in the sunlight and the lux drop below the threshold, it will turn in sun to false. Calculates how long the sunlight burst lasted and add it to daily total. After that, we had made in setup function which runs once at a startup, and the code begins serial communication at 115200 baud for the debugging. It initializes the I2C and start the BH1750 sensor, printing confirmation if then to if this connect to Wi-Fi, and set the starting point for the daily timer. Then after that we had made the loop. The loop function runs continuously every second. It calls the check sunlight. So now let's run the code, upload the code. So as you can see, the code has been compiled successfully and uploading. So as you can see, code has been uploaded. Let's open the serial monitor. So you can see, so let's see the hardware. This is the hardware. This is the hardware. So as you can see here, ground pin is connected to the ground pin of the sensor, and 3.3 volt to VCC, A4 to SCL, A5 to SDA. So as you can see here, if we come the sensor to the light, it will increase the readings. Here you can see it, and after increasing the value from 200, it will show sunlight started, and then when the value gets below 150 or 100, it will show sunlight stopped. So as you can see here on the IFTT, I can show you in the activity bar. It is also sending the values here about sunlight stopped, sunlight started. This is our task. So let's check the hardware which I made on Lucid. Here you can easily see ground wire of the Arduino Nano is connected to the ground wire of light sensor, 3.3 volt to the VCC, A4 to SCL, and A5 to SDA. You can see it easily. Thank you.